Alright, so we're going to go through each of these questions. If you have specific questions or are not sure about something, make sure you're asking, paying attention, not on your phones. As many of you did not do well on this quiz because many of you are not paying attention throughout the lesson. Okay. For he has this. Okay.
He's going over the
So we're both doing it. We're just doing it in separate sections. Alright, for the first section, we needed to factor out a trinomial. Okay, factor this. It shouldn't say trinomial. Let's do that. We should be factoring out a GCF. So we need to find what do these two have in common?
3.
3. Yes. Is there anything else?
X.
They both have X. So if I'm dividing out 3 and X, I'm dividing that out of both. I need to keep my GCF. What's left?
3. X to the second power.
X to the second power, yes, squared. That's it. You should have 2 factors here, but they shouldn't be in the format of like a trinomial. Okay. Do you have questions about that?
Nope. 3.
Some of you that did not get this should be writing this down, fixing this on another sheet of paper. If there's not enough room on your paper to fix it, put it on another sheet of paper. Beta. Say that one more time. Going over the quiz right now. So no to that part. You can take the test later. For this first, do we have any other questions on this one? What do these all have in common for the second one? 2. Divide each by 2. So if I divide each by 2, so notice this is not 2r because all of them don't have an r, just 2. What's left?
2. 3r.
3r squared
Plus 2r.
Plus 2r
Plus 6.
Plus 6.
No, I can't
Everything
take one more step
2 comes up
towards
front,
you,
and then everything that's left stays.
'cause all that's waiting is regret.
Any questions on that? That's what I thought. Okay. For the second objective, factoring with grouping, we need to split this down the middle. And then we're looking for just the GCF of 2, the first 2, and then the last 2. So of the first 2, what do these have in common?
5b.
5b squared. They have at least 2 v's in common. So if you just took out one v, you would still have multiple v's you could take out. If we divide both of these by 5b squared, what's left? 5b for the first one, and then plus 1 for the second. What could we divide out of the second 2? 6. Whatever this sign is, bring this down so that it's a plus. And this would be plus 6. And if I divide these both by 6, what's left?
5 and 1.
5b plus 1. And then you need to write your final answers as factors. What would those factors be?
5b squared. 6. Oh, plus put that in. And then put another parentheses. And that would be 5b plus 1.
So 5b squared plus 6 and 5b plus 1. Do you have any questions on how we solved that, how we got that final answer, anything related to that one? If, let's say you didn't factor out 5b squared and you only factor out 5b, then your insides wouldn't match, and that would tell you something's wrong. Also, let's say that at the beginning we could have factored out a GCF, but you didn't see that. A GCF out of all 4 instead of just out of 2. Then you would end up with something like this. So I'm going to make up 2 factors. So let's say we got 2 factors that look like this. That would mean you can still factor that out more. So always look at your factors. Look and see, is there anything else I can take out of this? If there is, take it out of that. So this would be 5b squared plus 6. I could take out a 5, and this would be b plus 1. So always simplify, whether it's at the beginning or at the end. If you did it at the end, that's fine. That just means you could have done it at the beginning. If you do it at the beginning, just make sure you bring it all the way down. Have any questions about what I just said?
Can I go now?
The second one, we're going to do the same thing. Split this down the middle. What can we divide out of the first 2?
4.
4. Is that the only thing we can divide out?
M squared.
M squared. They both have at least a 4. They both have at least an M squared. When you start dividing, if you don't get the same insides or your numbers look like you could still divide out something, you probably didn't divide out the highest GCF. What's left when you divide these out?
7
7
M
M
plus 4.
And what could we divide out of the last 2?
3.
3, but this would need to be a negative. Whatever the sign is, bring it down. And if you divide out negative 3, what's left? 7m plus 4. And then in our last step, we need to write our 2 factors. What would they be?
4m squared.
Minus 3. And the other? 7m plus 4. Find your GCFs of both set of numbers. Divide that out of the 2 numbers. And then write your final answers. Do we have any questions or confusion on either of those? For objective 3, if these are all perfect squares, so 1 is a perfect square, 25 is a perfect square, x squared is a perfect square, then this is going to be in the format. You're going to have 2 factors where 1 is minus, 1 is plus. What times what will give you 1?
1.
1. You would put that in the format of this. So this has 1 first, so 1 would go first. What times what will give you 25? 5. And what times what will give you x squared? X times x. So you would put that next to your 5. Wherever your x term is, that is where it should be in your factors. And that would be your final answer. Always check for a GCF, but if the GCF is just 1, continue with this. If there is a GCF, divide that out first, because most likely, if there's a GCF, the numbers you're given aren't perfect squares. But once you divide out the GCF, they should be perfect squares. I will say, none of the answers on the test are prime, so don't think that. All of them will have some answer. Right. Same thing with the second one. 49 is a perfect square, 9 is a perfect square. A to the 4th is an even exponent, so we can divide it by 2. So we're going to have 2 factors, and we have a plus and a minus. What times what gives us 49?
7.
7 and 7. And then a to the 4th, we're going to split that in half, divide it by 2, so that would be a squared, right? And what times what will give us 9?
3.
3 and 3. So that would be our final answer. Do you have any questions, confusion on that section? The last 2 sections were either skipped the most or had the lowest scores, so everyone should be paying attention to those. For these, you're looking for 2 numbers that are multiplying to be the last number, but adding to be whatever the middle number is. What are 2 numbers that would work?
5.
5 and 3, but because we have a negative 15, one of them has to be negative.
5 and a negative 3.
Positive 5, negative 3. So if it's in the format m or whatever variable squared, where there's nothing in front of the m squared or whatever the variable is, your 2 factors, you're going to have 2 factors. The very first term is going to be whatever the variable is, so m. Then you're going to take this factor and put it in 1, and this factor and put it in 1. M plus 5, m minus 3. Do we have questions or confusion on how we got that? Some of you aren't paying attention and are not going to do well. For the second one, there's a number in front of your variable. Check and see if you have a GCF. I'm going to do this one 2 ways, just in case you don't see it has a GCF. So if you see it has a GCF, I can divide all of these by 5. You can start there. We divide everything by 5. We're left with n squared plus 2n plus 1. Then the inside looks just like this one over here. So I can look for 2 numbers that multiply to be 1, but add to be 2. 1 and 1 would work if they're both positive. So just like this one, I would have my 5 that I originally factored out. I'd have 2 sets of factors. I'd have my variable, n and n, and then my 2 plus 1s. Before we do this the second way, do we have questions or concerns or confusion on how we got that? This is going to go a little faster because it's also a preview as to how we would do these.
No.
That's fine. So if you didn't see that it had a GCF, you would be taking 5 and 5 and multiplying it together. So we're looking for two numbers that multiply to be 25, and this is how we would do all of the questions in Objective 5. But they need to add to be 10. What are two numbers that would multiply to be 25 but add to 10?
5.
5 and 5, if they're both positive. So if you don't see that they have a GCF, your next step would be to take your first term, keep it the same. Take your two factors you just found, put those next to this, and make sure it has a variable. And then your last term. So that you have 4 terms now. Here, you should definitely have seen that's a lot of 5s. I can factor out a 5. Even if you still didn't see that and kept going, that's okay. So if we split this down the middle, out of the first two, we can divide 5 and n. And that would leave n plus 1. Out of the second two, we could divide just 5, leaving n plus 1. And in our final factors, we would have 5n plus 5 and n plus 1. And as you're looking at your final factors, bells should be going off that this is not completely factored because I can still divide out a 5 here. So if you divide a 5 out of this, then that one would become n plus 1, and you already have the other n plus 1.
That was way longer.
Yes. So if you don't factor out the GCF, it's going to become long really fast. It can still be done, but you still have to factor out your GCF at the end. What questions do we have on that one? Let's go through these last two, and then if we have no other questions, we'll start the test. So for Objective 5, all of these are done the same way. First, check if there's a GCF. If there's not one, or if it's just one, then move on to this next step. Take the first number and the last number, multiply them together. So we're looking for two numbers that multiply to be negative 40, but add or subtract to be negative 3. You may need to, on your calculator, divide by 2, 3, 4, keep going until you find two numbers. What two numbers were it?
Negative 8 and positive 5.
Negative 8 and positive 5. Also be careful with your, whichever is negative and positive, because that could throw off the entire thing. So once we have those two numbers, first term stays the same, 2r squared. Take the middle two, or take the two numbers you just found, put them in the middle. So minus 8, make sure it has a variable, r, plus 5 with an r, and then your last term, minus 20.
Wait, so let's say you kept it, like you knew which one was positive, which one was negative, but instead of putting first negative 8, putting 5, r, and then negative 8 would change?
The answer, the final answer,
Yeah.
would not change the final answer. It would change how you factor out the grouping, but that's okay because your final answer would still be the same.
Okay.
Split this down the middle. What can we divide out of the first two?
2, r.
2r. And what would be left?
1, no, r.
R minus 4. What can we divide out of the second two?
5.
5. Positive 5. And what would be left?
1.
R minus 4. And then our final two factors would be what and what? R plus 5 and R minus 4. What questions do we have on that? For the last one, same thing. This does not have a DCF, so we can take 6 and 8 and multiply those together to get 48. And we're looking for two numbers that multiply to be 48, but add to be negative 49. When those two numbers are close, it's more than likely going to be whatever the top number is and 1. 48 and 1 would work, but they both have to be negative. And then we would begin this process. 6t squared minus 48t minus 1t plus 8. Later, as soon as I finish this problem. And then we could split this down the middle. What could we divide out of the first two? 6 and t. What would be left? T minus 8. What could we divide out of the last two? 1, but it would be negative. And what would be left? Minus 8. So what would the final factors be?
Plus negative 1.
6t minus 1.
Yeah.
And
Plus minus
what was the other one?
1. And
T minus 8. Do we have any other questions on this? Any last minute things we want clarified?
Oh, can I go to the bathroom for a try now?
One T5? If you don't have any additional questions, go ahead and clear up your desk, put your cell phone